So I'll be back to check for latecomers at around the 15-minute mark, like I usually do. I hope everyone is doing well. We are at the end of week 11, right? So we have exam. Sorry about that. We have exam 3 that's scheduled to become available this upcoming Sunday at 11:11 a.m. and it'll be due the following Sunday at 11:59 p.m. Right? So the usual stuff there. So that means next week it will be an exam week. So I'll just be just coming to class just to take attendance, and I'll be available for questions. You can ask me questions about anything that's on Pearson, even your current live exam, right? Yeah. So I can't think of anything else. So the main thing here, we're just gonna take some time today to go through as many. 9 a.m. session was a good session in that yeah, we kind of jumped around a little bit, and like some of those questions towards the back were like, I'm glad we talked about those. So you can always check out that video. It's in the same playlist that this one usually gets uploaded to. I do need to go and update those videos, but yeah, you can always watch. I have like a total of 4 college algebra 1 sections and then 1 college algebra 2. You guys don't need the college algebra 2. Let's see. So here we're actually using synthetic division to find the quotient and remainder when the first polynomial is divided by the second. Okay, so let me go ahead and get a copy. And let's take this and we're going to work over on notability here. Okay. So if we're going to do synthetic division here, if we're dividing by x minus 1, the 0 of that needs to go into the chair. So that means 1 goes into the chair. Then we need to write the coefficients, making sure that every power is accounted for. So we're going to have 2, 1, -6, 1, -1, -2. Okay, let me see. So if we started with the degree 5, we should have 6 numbers: 1, 2, 3, 4, 5, 6. So that means we don't need any placeholders. The first number just comes down. On the diagonal, we multiply, then we add, we multiply, we add, multiply, we add, multiply, we add, multiply, and that adds up to a -5, and that's our remainder. Okay. So then, because we started with the degree 5, at this stage, our depressed equation is now a degree 4. Okay. And we have a remainder of -5. So what we're gonna do is here. Oh shoot, looks like they booted us out, so it probably did not save our work. Let me see. Yeah, we probably lost it. Well, that sucks. I don't understand why it does that. Allow. We might have to do it again right here. Okay, let's do it again. Oh, and you know what might help? I think if I hit save, I think as long as I hit save before we leave, if we get booted off, it'll bring back our same question. Just hit save. Okay. Yeah, let's just do it again. Okay. So again, if we're doing synthetic division, 2 goes in the chair. We have 1, 1, -7, 1, 1, 1, right? We started at degree 5, so we should have 6 numbers, 1, 2, 3, 4, 5, 6. So we don't need any placeholders. 1 comes down, 2 times 1 is 2, 3, 6, -1, -2, -1, -2, -1, -2, -1. Okay, so that's just how it worked out. So at this stage, we're at a degree 4. Okay. So now let's try to submit this one. It should be the same because we hit save. That is a pain to have to do that at each step, but as long as it keeps the same numbers, then it's worth it, in my opinion. Let's go like this. Okay. All right, I think we're okay. Let's turn that off. So the quotient that we get, okay, x to the power of 4 plus 3x squared plus 3x squared. Sorry, 3x cubed minus x squared minus x minus 1 minus x minus 1, and the remainder is -1. Okay, let's see how to do. Okay. Let's see, can that work side by side? Let me see. If I do like this. Okay. I know that's probably small, but I'm going to rewrite it so that you can see what's going on as soon as I can get this to behave. Let's go like this, and then like this. Let me add some added security and hit save. So that way it should stick to that number, those numbers. Okay. I'm just gonna kind of articulate it. I know the text is small, but I'm gonna try to work with this and see if this behaves a little bit better. Okay. Okay. So this is question, oops. This is question 2. I don't want to do it. This comes from section 2.3, question 5. And I'm just going to abbreviate it by synthetic division. Okay. So then we have x to the power of 6 plus 4x to the 4 minus x cubed plus 5 divided by x plus 2. Use fractions or integers. Do not factor the quotient and the remainder. Okay. So again, we can only do synthetic division when we're dividing by a linear binomial, so we're good to go there. Into the chair goes the 0 of this linear binomial. In this case, the chair is going to take on the form of -2. Okay. Now it looks like we're going to need some placeholders here. All right. So the first coefficient is a 1. Since the power of 5 is missing, we need a placeholder there. Power of 4 ends up being 4, -1. Then it looks like we need 2 more placeholders for the power of 2 and the power of 1. Power of 0, which is the constant term, is this. Okay, so we need a whole bunch of placeholders there. Okay, so then the first term just comes down. On a diagonal, we multiply, we add, we multiply, we add. -16, -17, +34, 34. What is that? 68, -68. 120 plus 16, 136. So then 141 is our remainder. Okay. We started with a degree 6, so then at this stage, we have a degree 5. Cubed, squared. And I'll check attendance around in a couple of minutes. Okay, so let's try submitting this. Let's see if I can just type it here. We don't need that box. Yeah, all we need is this. Okay. So then we have x to the power of 5 minus 2x to the power of 4 plus 8x cubed, 8x to the power of 3 minus 17 x squared, 34x minus 68. Okay. Let's go with that. And then the remainder is 141. Okay. All right. That kind of worked. Can we just go into the next question? All right. Use synthetic division to find the quotient and the remainder when this polynomial, so it's a similar, I'm gonna just hit save. So that way, if we get booted, we'll be working with the same one. Are we just on the third question? Okay, that's fine. Yeah, I'll do this one again after attendance. Okay, so then this is question 3. This comes from section 2.3, question number 7 from the back of the text. And let's actually drop down. Okay, let's drop down here. And I'm just going to abbreviate it by synthetic division. Okay, we have this 8x cubed plus 14x squared minus 2x plus 1. We want to divide that by x minus 1 over 8. Okay. Let me see. 1, 2, 3, 4. So we don't need any placeholders. So then we are dividing by a linear binomial. And so basically the 0 goes in a chair. So then the 0 in this case is 1 by 8. Okay. We take our coefficients of 8, 14, negative 2, and 1. Okay. The 8 comes down. That's a 1. That's what? Okay. That's 15. Let me see. 15 over 8. Nothing. So 15 by 8. 16. So then a negative 1 by 8. You multiply, you get a negative 1 by 64. 64 minus 1 is ultimately going to be 63 by 64. That's our remainder. Okay. We started with a degree 3. So now we're at a degree 2. Okay. Use integers. Use synthetic division. We just want the quotient and the remainder. The quotient ends up being 8x to the power of 2 plus 15x minus 1 over 8. And the remainder is 63 over 64. Okay, let's go with that. Okay, let me check Zoom. Let me check you guys in Zoom. Okay. How did everybody get booted? Okay. Yeah, I don't know how everybody got booted, but it's fine. So we're here now. Welcome back for some of you, and welcome for others. Anyway, let's keep going. Start the stream. All right. So we're going to suppress this. All right, let's do another one. Come on. Let's see. So we're asked to do synthetic division. So I'm gonna, because it's kind of been crashing a little bit. So I'm gonna leave that kind of suppressed on the left-hand side. That way I'm not like exiting out so much. So I reduce my chance of it crashing and losing our work. This is question. I'll just write it out so that you can see it. This is question number 4. It comes from section 2.3, question number 9 from the back of the text. Is again synthetic division. All right. Okay. We got 2x cubed minus 9x squared plus 2x plus 8. We want to divide that by x plus 3/2. Okay. So that means a negative 3/2, which is as 0 goes into the chair. Since we have a power of 3, we need 4 terms. We have all 4 terms, so we don't need any placeholders. So we take our coefficients of 2, -9, 2, and 8. The 2 comes down. Let me clean this up. The 2 comes down. When we multiply, it looks like we get negative 3. We add, what is that? -12. 6 times 3 is 18. So 20. 10 times 3 is a -30. 22. -22. Okay. Since we started with a degree 3, this depressed equation is now a degree 2. Okay. Submit that. Okay. Close this out. So we got 2x squared minus 12x plus 20. And the remainder is -22. Let's go with that. So another one. Could, I guess. I think it's fine to wait. I think, how do I want to do that? Use synthetic division. Okay, what number is this? This is number 5. Use synthetic division to find P of K for the given value of K and the given function. Let me see. To find P of K. Okay, so we're replacing X with 3. Synthetic division to find P of K and the given function. Okay, so that sounds like the remainder theorem, where you're basically doing synthetic division, where 3 goes into the chair, and then P of 3 is the remainder, right? So that's what it seems like. It's just like the remainder. Okay. So let's see. This is question number 5. Come on. This comes from section 2.3, number 11. I'm not going to write all of that, but we have our K equals 3, and we have P of X equals X cubed minus 5X squared plus 5. Okay. So if we're going to do, basically we're doing synthetic division. Let's do our 3 in the chair. Since we have a degree 3, we're supposed to have 4 terms. We need a placeholder. So it looks like the power of 1 is missing. So we're going to need a placeholder. 1, -5. Right here, we need a placeholder. And then 5. Again, we have a degree 3 polynomial. So we needed 4 terms. So we're good to go there. The first term just comes down. 3 times 1 is 3, -2, -6, -6. -18, -13 is our remainder. Okay. So since we started with a degree 3, at this stage is now a degree 2. And let's submit that result. Oh, so then the result is negative 13. So then P of 3 should be negative 13. Okay, so it was a remainder theorem. You could have also just evaluated. You could have plugged in that negative 3 and just gotten a result as well. Okay. Use synthetic division and the remainder theorem to find an indicated function value. Basically, evaluating this when x is 2. So what I'll do for this one, okay, this is question 6. This comes from section 2.3, question 13. I'm just going to abbreviate it as the remainder theorem, whatever. Okay. We have our f of x is x to the power of 4 plus 4x to the power of 3 plus 7x squared minus 6x minus 6. And we're actually using the remainder theorem to evaluate f of 2. Now, we could just plug in the 2, but we're going to get, well, the numbers don't, I mean, we'll get a whole bunch of numbers, but instead, this will probably be much easier to just do the remainder theorem, i.e. synthetic division. So 2 would go in the chair. Let's do our coefficients. So we're going to have 1, 4, 7, negative 6, and 6. We started with the degree 4 polynomial, so we should have 5 coefficients. 1, 2, 3, 4, 5. So we're in the clear there. So then we just do our synthetic division. 2, 4, and 2 is 6, 12, 19, 38, 30, 2, 64, 50, 58, right? Okay. So that means that f of 2 should be 58. Thank you. F of 2 should be 58. Let's go with 58. Submit. All right. Let's check on you guys on Zoom. Okay, get these students. Come on. Okay, he was here already. This one. Okay, go back to share my screen. And we're gonna kind of hop back to here. Okay. All right. So we're asked to use the factor theorem to determine whether the first polynomial is a factor of the second. Okay. Factor theorem. So in other words, when we do synthetic division with this dividend divided by this divisor, the remainder should be 0, right? If it's a factor, the remainder should be 0. Okay, so let's take some notes. So this is question 7. This comes from section 2.3, question 15. We're going to say, is it a factor? Is it a factor? Question mark. We got this x plus 6 divided into x cubed plus 10x squared plus 19x minus 30. Okay. So if it's a factor, when we do synthetic division, the remainder should be 0. Okay. So first thing is, because we're dividing by a linear binomial, we can do synthetic division. Negative 6 needs to go into the chair, the 0 of the linear binomial, right? Because we have a degree 3 polynomial, we need 4 terms, 1, 2, 3, 4. So we don't need any placeholders. So then we need our coefficients of 1, 10, 19, and negative 30. Okay. The 1 comes down, negative 6, 4, negative 24, negative 5, 30, and 0. All right, so we did get a remainder of 0. Okay, we started with a degree 3, so that means this is now a degree 2. Okay, And again, if anything is not clear, you just have to speak up. All right, you have to get my attention, and we can adjust or whatever as needed. Okay. So the first question is x plus 6 a factor of this dividend? We're going to say yes because we got a remainder of 0. Oh, that was it. Okay, cool. Same kind of deal here. Decide that this is a factor. So remainder theorem. If the remainder is 0, then it is a factor. Okay. Come on. Are you really gonna? Come on. All right. So then this is question 8. This comes from section 2.3, question 17. I'm going to say factor, or is it a factor? Question mark. We have 4x to the 4 plus 9x cubed minus 14x squared plus 59x plus 3 when it's divided by x plus 4, right? So that means negative 4 will go in our chair. Our coefficients are going to be 4, 9, negative 14, 59, and 3. We started with the degree 4, so we should have 5 coefficients, 1, 2, 3, 4, 5. So we're good to go there. Okay, the 4 comes down. 4 times 4 is going to be negative 16. That's going to be negative 7. Positive 28. Positive what? 14. 40, this is plus 16 is 56. So negative 56. 3, negative 12. And it adds to negative 9. Okay. And then we started with the degree 4, so now this is a degree 3. Okay. So then, is x plus 4 a factor of this dividend? We're going to say no. I guess that was it. Thought we had to do some more, but that's it. Okay. I kind of want to skip this one. Yeah. I mean, let's just do it. It's not going to take us that long. Because I want to get to some of the others, but you could always, I would encourage you to like watch the video from my 9 a.m. today. It got a little interesting. Let's see. So this is question 9. Come on. This comes from section 2.3, question number 19. I'm going to say, is it a factor? Is it a factor? Question mark. And so we have f of x equals, we got this x to the 5th minus x to the 4 minus 8x cubed plus 8x squared minus 9x plus 9. We want to know when that's divided by x minus 3. Okay. So that means 3 goes in our chair. Okay. Our coefficients are 1, negative 1, negative 8, 8, negative 9, and 9. We started with degree 5. We should have 6 coefficients, 1, 2, 3, 4, 5, 6. Okay. So we're in the clear there. 1 comes down. 3, 2, 6, negative 2, negative 6, 2, 6, negative 3, negative 9, and 0. Okay. So we started with the degree 5. So now we're at a degree 4. Okay. Now, hopefully you should see that it's essentially, so far we've been doing the same thing every time, just different numbers. Is it a factor? We're going to say yes because we got a remainder of 0. Oh, that was it. Okay. All right. Tempted to just put this in the calculator. Let's see if I can pull up my calculator. You're going to force me to do that. There we go. That's exactly what I want. Okay, this will work. Okay. So I'm gonna put this in the calculator to see if it goes a little bit faster. So my y equals, I'm gonna type my polynomial. I was kind of going on the frizz. This is what I was trying to avoid. Let me see. I think this might work if I leave it like this. That's what I need. All right, that's fine. I can see what I need there. Okay, so then we have this x hat, x to the power of 5, that's not a 5, plus 2x to the 4 plus 2x to the hat 4 minus 8x to the power of 3 minus 8x hat 3 minus 16x squared minus 16x squared minus 9x minus 18. Okay. Okay, that looks good. So then if we evaluate this when x is -3, you know, let's see. So let's call on that function. When x is -3, if it's a factor, the remainder should be 0. It is. So then is it a factor? We're going to say yes. Okay. Find the case. So this is where it got interesting. One of the students early on in the class from this morning was like, hey, can we do 11 and 12? So it looks like we are going to have time to get through 11, but then it was the questions after 11 and 12 that it started revving up. It was like, oh man. And so we got through a good amount of them. We went through some interesting questions. We're kind of out of time here, so that's why I was encouraging you guys to check out the recording from this morning at 9. Okay. We'll do what we can. So this is question 11. This comes from section 2.3, question 33. I'm going to say find a k such that f of x equals, we got x cubed minus kx squared plus kx plus 9 has the factor x minus 3, okay? So if x minus 3 is our factor, when we do synthetic division, the remainder should be 0, okay? So into our chair goes 3. So then we take our coefficients. Let me see. 1, 2, 3, 4, okay? So our coefficients are going to be 1, negative k, k, and 9. We're essentially just doing the same thing, just adjusting for the changes. Let's go ahead and do our synthetic division. So the 1 comes down, 3 times 1 is 3. If we add, we're going to get 3 minus k. If we multiply, we're going to get 9 minus 3k. If we add, we're going to get 9 minus 2k. If we multiply, we're going to get 27 minus 6k. And then if we add 36, we're going to get 36 minus 6k as our remainder, right? But in order for this linear binomial to be a factor, that remainder has to equal 0. So then we're going to say 36 minus 6k, we're going to set that equal to 0 and solve. We'll get 6k equals 36. So then k equals 6. Okay, hopefully that was okay. So then we got a 6 here. So I'm just going to put 6 and go on. Okay, I think the next one was similar. Okay, I'll do another one. So this is question 12. This comes from section 2.3, question 25. Okay. Same kind of deal. Find a k such that we got this f of x equals, we got x cubed minus kx squared plus kx plus 21 has the factor x minus 3. Okay, so that means 3 goes in our chair. Our coefficients ends up being 1, negative k, and 21. Same kind of deal. 1 comes down, 3 minus k, 9 minus 3k, 9 minus 2k, 27 minus 6k, 48. 48 minus 6k is our remainder. But if we want it to be a factor, that means that 48 minus 6k needs to equal 0. 6k equals 48. It's 8, right? K equals 8. Dog is snoring like a grown man over there. And she's a chihuahua. It is hilarious. She is like, it's so funny. All right, so we got 8. Let's submit 8. All right, let me see the time. We got time for one more. We'll do one more, then that's it. Use the factor theorem to check whether this polynomial is a factor of this. Find the remainder when this. Okay, so for it to be a factor, that means the remainder has to be 0. So I think I'm just going to do this in my calculator. Let me kind of clear out the space. So if I go to my y equals, we have negative, which is here, negative 3x to the power of 3, 3x hat 3, okay, plus 13x squared, so plus 13x squared, okay, minus 24x, minus 24x, and then plus 40, okay. So that's our function. So then we want to divide that by x minus 3, so that means that when we do synthetic division with 3, the remainder should be 0. So in other words, if we just evaluate this function when x is 3, we get 0. We did not get 0. So is x minus 3 a factor? We're going to say no. No. We're going to say no. Okay. What's the time? What is the remainder? We might need to do synthetic division. Oh, no. The remainder is 4. Okay, let's do one more. I think the next one's similar. Use the factor theorem to decide whether x plus 5 is a factor of this guy. So I'm just going to do it in my calculator again. We got this 4x, let me say 4x hat 4 plus 10x hat cubed minus 12x squared minus 12x squared plus 194x plus 194x plus 2, okay? So I want to call on this function when x is negative 5. Okay, so we got a remainder, so it's not 0, it's just a factor. We're going to say no. And we got a remainder of negative 18. Oh, that was it? Okay. See, and like, all right, let me see. All right, I will touch on this one. We're out of time. Let me see if I can get this to behave. I think maybe if I like zoom in. Okay, there we go. All right, so let me touch on this one. This is an application on the rational zero test. The rational zero test comes out of doing all the combinations with the factors of the constant term divided by the factors of the leading coefficient. So in this case, the constant term is 1. The leading coefficient is 3. The factors of 1 are just 1. So for instance, we're only working with 1 and 3, so it can't be B because it has 8 in there, and it can't be D because it has 8. There's no 8 in the constant term or the leading coefficient. And then if it's the constant over the leading coefficient, it can't be A because it's missing our fractions. It's just, A is just off, right? So then what this list tells us, if this polynomial has rational zeros, it's going to be somewhere in this list, right? That's what this is telling us. If this polynomial has rational zeros, it's going to be somewhere in this list. I think we can do maybe one more. So the list of potential zeros is basically going to be the factors of 1 divided by the factors of 11, B, right? Okay, this is a good one. Find all the right, this is it for the day. Okay, I do need to write it out. This is a little bit pushing it, but let's go. This will be the official last one. So I need to give myself a break to get ready for the next class. Okay. So we're asked to find the actual zero. So we can start with the rational zero test to give us a list of possible rational zeros. And then if this polynomial has any rational zeros, it's going to be somewhere in that list. So if we did a rational zero test of our P over Q. Okay. So the factors of the constant is 10. So that's going to be plus or minus 1, plus or minus 2, 5, right? Plus or minus 5, and then plus or minus 10. Those are the factors of 10. And we got fortunate that the leading coefficient is 1. So then it just ends up being just the numerator. Right? So again, if this polynomial has rational zeros or somewhere in this list, it's generally a good idea to go ahead and start with 1, right? That's a simple one. Let's just start with 1 to test, to try to find that 0. Our coefficients end up being 1, 8, 17, and 10, okay? Looks good, 4 numbers. So then we get 1, 1, 9, 9, 26, 26, 36, okay? That is not a 0, right? 3, 2, 1, 0. 1, 8, 17, 10. We can try -1, all right? So let's redo this with -1. 1, 8, 17, and 10. 1, -1, 7, -7. That's promising, right? Because then we get 10, -10, and we got lucky indeed. So we found one of our zeros. -1 is one of our zeros. Okay, so let's list out what we have at this point. So if -1 is a 0, then that factor is going to take on the form x plus 1, okay? And since we started with a degree 3, that means at this stage we're now at a degree 2, okay? So then we have x squared plus 7x plus 10. Let's see if we can factor that guy. X and x, plus and plus, 5 and 2, right? 5 and 2. So then our zeros look like they are -5, -2, and -1. Because we're out of time, I'm not going to check this. I'm just going to submit it on Pearson. But if I had more time, I would check it. -5, -2, -1. -5, -2, -1. -5, negative. That's not. These are not negatives. -5, -2, -1. Oh, come on. Thank you. All right. All right. On that note, we are out of time. Did you guys have any questions? I feel like there should be questions, but you know, I get it. While you think about some questions, let me go ahead and make a copy of this available. fall, this one, notes, updated daily. Okay. So when this bar finishes loading, you'll get a copy of anything that you saw me writing. If there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day, guys. Take care. Peace.